Okay, off we go into a little journey into the duodenum. This is my favourite region of the gut. Don't know why, just is. Just love it. So again, we need to know the sort of modifications, the adaptations for what it does. So remember, this is the bit that follows immediately after the stomach. So it's heading, the chyme is heading off through a sphincter. So when you've made all your sort of solid chunks into chyme, it'll head off through the pyloric sphincter and into the duodenum, and this is acid. So the duodenum is kind of geared up for making things back to alkali, also doing digestion, and also having a nice big surface area to do a bit of absorption as well. So if we look at the layers of the gut, obviously we've got the serosa on the outside. Then we've got our longitudinal and circular muscle layers, so they can do peristalsis. And then we've got the submucosa, so that's this area here between there and there. And this is characterised by having glands in it, submucosal glands called Brunner's glands. And what these do is they secrete alkaline mucus. Mucus-rich alkaline secretion. What makes it alkaline is bicarbonate. And then we've got the villi. So these are to increase surface area, and of course the cells have microvilli, so it's got a massive surface area. And sort of down here in the mucosa we have mucosal glands, and these are called crypts of Lieberkuhn. There are such fantastic terms associated with the gut, you know, so there's plexuses like Meissner's plexus and Auerbach's plexus, and you know, you should check those out, they're great. Crypts of Lieberkuhn, that always reminds me of, you know, somewhere you might go to on holiday, and these do cell replacement. You've also got Paneth cells which secrete enzymes and hormones, and you know, they're sort of doing quite a lot of secretion. But the main thing about the duodenum is it's the only place where you find Brunner's glands producing this alkaline bicarbonate to reduce the acidity. But it's also, the most important thing is this sort of idea that it's also receiving secretions from external glands. So we'll start with the liver. The liver makes bile. Bile is quite alkaline, and it's stored in the gallbladder, and it moves down into the duodenum through a bile duct. Now obviously there's more to that story. There must be a way of detecting, is there some fat in this food coming through, and the more fat there is, the more bile you'll secrete. So it's coming down through this bile duct and feeding directly into the duodenum. Now bile is not an enzyme. This is an emulsifying agent, and it emulsifies fat. So, you know, if you've just had, you know, chips and burgers, something really greasy, that fat in the acid chyme is going to form big droplets because it doesn't dissolve in water. So what emulsification is it's making those big droplets of fat into much smaller droplets, and that then is going to increase the surface area for lipase enzyme. And the lipase is going to do, so lipase is going to do hydrolysis. So it's going to hydrolyse ester bonds and release fatty acids and glycerol. And if you remember, last year in the core you will have done an experiment into lipase using phenolphthalein, making the milk go pink, and as the fatty acids are released, pH goes down in the solution and the pink colour disappears and goes colourless. So that's to do with the acidity causing a pH change. Bile is also, and for some reason this is something students always remember, bile is also alkaline, so it's going to help reduce the acidity of this acid chyme. So we've got alkali from in bile, we've got alkali from Brunner's glands, and our other source of alkali is pancreatic juice. Now pancreatic juice contains bicarbonate, which is our main thing that's going to reduce the acidity, and it also releases a number of enzymes, and this is an exocrine secretion. So the pancreas, really interesting. It has an endocrine function. So endocrine, you're effectively talking hormones. So we've got insulin and glucagon, which do opposite things, and they're going directly into the bloodstream, which is why it's called endocrine. Exocrine means that it's going into a duct, so that duct is going to be packed out with bicarbonate and enzymes. And of course, interestingly, this is another of my holiday destinations. The endocrine cells in the pancreas are called the islets of Langerhans. Also sounds like a nice place to go on holiday. And when you're there, you could go and visit the crypts of Leverkusen. So, what enzymes does the pancreas release? Well, again, it's releasing endopeptidases. And it releases them in an inactive form. So our inactive form, start with trypsinogen. So remember, these are the ones that are going to break bonds in the middle. And this is activated into trypsin by enterokinase. We've also got chymotrypsinogen, and that's activated by trypsin. So trypsin not only does sort of endopeptidase things, but it also activates chymotrypsinogen into chymotrypsin. It also releases carboxypeptidases. So we've got carboxypeptidase. This is an exopeptidase. And if you remember, all proteins have an amino end and a carboxylic acid end. And these actually hydrolyse the peptide bonds, but only at the carboxylic acid end. And there are other exopeptidases that do the other end, but they're sort of embedded into the microvilli with the dipeptidases. So, what else? What other enzymes do we get? We've got amylase. So we call this pancreatic amylase as opposed to salivary amylase. That's going to convert starch into maltose by hydrolysing glycosidic bonds. And then we've got good old lipase coming from the pancreas, and that's going to hydrolyse ester bonds to release. So we've got lipid going into fatty acids and glycerol. Now that's quite a lot of stuff, isn't it, going on in there? That's why I love it so much. So what do you need to remember? Definitely Brunner's glands. You need to remember your sources of alkali, why they're needed to reduce the acidity of the chyme. Passing through, you need to know these enzymes, coming through in pancreatic juice, and you need to know the function of bile and what it does in that in the duodenum. Interestingly, just a little bit of synoptic for you. One of the issues for people who suffer from cystic fibrosis is that obviously the mucus that's produced is very, very thick and sticky, and it can block this pancreatic duct, which then means that the enzymes all stay in the pancreas and cause inflammation, and so one of the sort of treatments to alleviate the symptoms would be to take additional digestive enzymes. So you know, if you can't get the enzymes out to digest the food, you're not going to be able to break down the stuff you're taking in, and also sort of the inflammation idea of the pancreas. So that's one of the areas from Unit 2, synoptically speaking. Okay, well, that's the duodenum for you. Really interesting.